Natural interaction with physical objects may include picking them up, using finger dexterity to rotate, observe, and even squish them, and finally, releasing them. TORC is a proof-of-concept system, rendering haptic sensation of non-rigid, compliant materials using a rigid controller, and enabling users manipulating objects through natural gestures using the dexterity of their fingers. TORC was designed to support precision grip using the thumb and 2 fingers. The index and middle finger rests were built as one piece. A VCA provides vibrotactile sensation to both fingers. A force sensor under the thumb rest measures the pressure applied on the controller by the fingers. Finally, the user can slide his thumb freely along a capacitance-based 2D trackpad parallel to the other 2 fingers. When the user slides her thumb on the trackpad, it rotates the virtual object, enabling fine movement of the object, while the hand itself may be supported and static. The index and middle fingers do not move in reality, but in the virtual image of the hand, they are rendered rotated in the opposite direction of the thumb, to the pose as if the object is rotated. The semantics of the motion may change according to the context of the application. For example, when holding an object such as a screwdriver or a key, its rotation may be bounded to 1D rotation around a given axis, or in the case of a slippery object, the actual angle of rotation may be dependent on the force applied by the thumb. Applying inward force of the thumb toward the fingers would cause a visual animation of the virtual fingers closing in on each other, possibly modified by the presence of an interposing virtual object. A negative force on the finger rest indicates the system outward extension of the fingers. When holding an elastic object, the user may apply force between the thumb and the opposing fingers to squeeze the virtual object. Although the user's physical fingers do not move, the combination of the visual stimuli accompanied with the rendered haptic sensation combines to a compelling experience. Sensing the 2D movement of the thumb and the force applied, TORC plays the texture feedback. The amplitude of the texture increases proportionally to the speed of the thumb. TORC was designed to be simple and robust, with no actuators working against the user force, and could be easily incorporated in durable commercial controllers. We presented TORC, a rigid controller that enables a user to perform dexterous finger-based interaction and exploration of a virtual object.